Hey, this is Madhu. Welcome to my channel. Today we are going to discuss about Retrieval-Augmented Generation or RAG system. We will see what is RAG, what's its usage, how can we build, deploy a RAG model and expose it as an API service and then consume this API from a web application. At the end of this training, you will be able to build an application having a user interface like this, where you can ask questions which will be responded using a RAG model referencing a knowledge base. If the questions are out of context or not in the reference knowledge base, then the system will acknowledge its incapability to answer your question. Clear button has been provided to reset the chat history. The best part is that the entire application including LLM we are going to deploy and run on the localhost. So there is no LLM subscription or API call needed to run this application. But if your system doesn't have GPU, you can easily modify the code to consume an LLM API service to implement your RAG system. Let's move on. First we'll see what is the problem that RAG is going to address. LLMs excel in providing precise answers related to the information they were trained on. They often struggle with hallucinating responses when confronted with topics that were not present in their training data. Since ChatGPT or any other LLM is trained using massive information from all over the internet and spits it out with confidence, it's difficult to determine when it makes up information. Here, RAG plays a crucial role by combining external information with language models to improve the quality of generated text. So what is this RAG or Retrieval-Augmented Generation system? RAG is an AI framework that improves the quality of responses generated by connecting the large language model to an external source of knowledge. With RAG, we can also ensure that the LLM has access to proprietary data by connecting it to custom data sources from where it can retrieve information. A RAG system primarily comprises two components, a retriever and a generator. Let's now go over the architecture and workflow of a RAG model which we are going to build today. As a reference document and setting context information for our RAG model, I am using a PDF file having 186 pages in it. It's not necessary that you have to use a PDF file as a data source. Rather, RAG can utilize various types of document or input data as reference sources. This includes text documents, web pages, structured data, knowledge base, conversational data, code snippets, emails, etc. Here I am extracting text from each page of the document. For building the retrieval mechanism, we need to embed the sentences as a numerical representations. For the optimal use of embedding model, we can split the page contents into chunks of sentences. Every embedding model has a token limit for input data. For example, sentence transformer model which we are using in this project can take input string up to 384 tokens. That comes approximately 280 words. And this model will turn the sentences into a vector of size 768. Here one token is approximately equal to 7 characters. That means it's almost equal to 0.75 words. You may have to perform some exploratory data analysis to get an idea about the size of the text in order to split and group sentences into chunks. After creating the document chunks, use an embedding model to turn them into numerical representations that can be saved for later. Here is the retrieval system. What it does is retrieve relevant passages or documents from the input data file based on the given user query. By doing so, it provides the necessary context and background for the LLM to produce accurate and informative responses. There are several options like cosine similarity, TF-IDF, graph-based models, etc. to find document similarities. The best choice of similarity search method depends on various factors including the nature of data, computational resources availability, and the specific requirements of the application. So far we have discussed about the data preprocessing and creating the sentence embeddings. Next we will see the RAG system workflow. Here the user sends questions to the RAG model through a web application, which in turn send a HTTP request to the server API. In this application, I use the popular Flask framework to handle HTTP requests from the server side. The user query will be embedded using the same embedding model that we used for embedding the PDF content. User query with its embedding vector will send to the retrieval system, where it will perform vector dot product similarity search to get the matching scores. In this project, I am returning top 5 records having highest similarity scores. You can decide on the matching documents count to be returned. Default value I have set as 5. In short, what's happening here is from the input PDF document, it's filtering the most relevant sections to be used for answering the user query with the help of LLM. After selecting the sentence chunks, we are generating a prompt for LLM using the user query and the retrieved passages. We will augment our prompt with a query as well as context from our PDF related to that query. There are many open source LLMs available to use. Since I am running the entire application locally based on my GPU configuration, I am downloading an open source Hugging Face LLM Gemma with 2 billion parameters. If you want best performance, then you will likely want to use an LLM API such as GPT-4 or Cloud. Basically, all the components used in this architecture are replaceable with higher or better versions based on your requirements. Here I am demonstrating the basic functionality of a RAG model today. Result generated from the LLM is sent back to the web application as HTTP response object. And this is the complete workflow which we are going to build today. Now let's go to the project implementations. For machine learning projects, I usually prefer Spider development environment. You can use Anaconda Navigator to launch Spider IDE. Click on the launch button to open Spider development environment. Let me go to the project folder. The folder structure I am using for RAG project is here. Config folder is used to store my Hugging Face access key in a TOML file. Data folder contains the PDF file which is used for setting the model context. For today's demo, I am using this ebook, Hands-on IoT Solutions with Blockchain, which is freely available to download from internet. This PDF file has 186 pages in it. SRC contains the folders API, components and utils and app.py file. Let's start with our file processing logic, which is inside the utils folder. Import necessary Python libraries required for the file processing and for creating embeddings. This line initializes a spacey language object for processing English text. It creates a processing pipeline for the English language. In this project, we are utilizing the spacey object for tokenizing text into sentences. Load data function takes a file path as input. It uses the fits library to open the PDF file and extracts text from each page. I've extracted all the library names with version used in this project to requirements.txt file so that you can utilize this to install all the required libraries. Every page in the PDF file contains chapter name and number as header that we can remove. Here is the code to remove header from every page. Here are some minor cleanups like replacing new line characters with spaces. Extracting the page number. The PDF file contains cover, title page and other informations at the beginning and the actual page number starts from 12th page. So subtracting 11 from the actual page number to match the page number printed on the page. Calculating the word count, sentence count, and getting the text from the page. Here the sentence end has been identified using the dot symbol. That's not completely accurate, but we'll get some idea about the sentences per page. Word count and sentence count are used for some exploratory data analysis to decide on the sentences chunks to be created for embedding. These page details are collected as a dictionary object and added to a list. This function returns the created list object. I'll run this function and see the result. Select the function and press F9 to run the code. It takes some time to load the language library for Spacy. Now here I am calling that function and setting the return value to a variable named data, running this line of code. In the Variable Explorer tab, you can see all the variables and their current values. Let me open this data. The actual file content starts from here, page number 1. For each page, we are getting page numbers, sentence count and word count are showing here. The text property contains the text extracted from the particular page. If we convert this to a pandas data frame, we can see the details in tabular format. Data frame allows to perform various EDA operations. By calling the describe method, it's showing the statistics. Min and max values of word count and sentence count per page. The minimum value of word count per page is showing 1. Minimum sentence count is also 1. Usually just one word or sentence will not contribute any meaning to the context. So there is a scope for some preliminary data cleanup. We can set a threshold token count so that pages having token count below the threshold value can be removed. This statistic will also help us to decide on the text length and grouping of sentences required for text embedding. Let me quickly show you the data frame format of our PDF file details. Page number, word count, sentence count, and text per each page. Next function, make send chunks, split the text content of each page into chunks of sentences. Passing the list of dictionary objects and sentence chunk size as parameters. The default value for sentence chunk size is set as 10. Adding a processing pipeline for tokenization. It utilizes Spacy's English language model to tokenize the text into sentences. So we are not relying on a dot to identify the sentence ending, but using Spacy pipeline and function call for that. So I am overwriting the previous approximate sentence count with the actual count calculated using Spacy. Then it calculates the number of chunks based on a specified sentence chunk size. The negative sign in the expression is a tricky way to achieve ceiling division in Python. For example, division of 22 over 10 with negative signs return 3. Let me quickly run this expression. The result is 3. Whereas if you remove the negative symbol and run the expression, you can see the result as 2. So for a text having 22 sentences, we need to split into 3 chunks of embeddings. That's why it requires a ceiling division to calculate the number of chunks. For the actual text split operation, we need not explicitly calculate the value like this, but we'll do it automatically. calculating this value just to show you the number of chunks it is going to create. Here creating the actual sentence chunks. This list of spacey objects which we are calculating here throws pickling error, so I am removing it from the dictionary. The modified list of dictionaries now contained sentence chunks is returned. Let me run this function. Select the function and press F9. Invoke the function, passing the parameter data, which is the list of PDF details that we received from the previous function call, and setting the return value to a variable named processed. If you open this list, you can see the dictionary object corresponding to each page, including the title page, TOC and all. For that, we have the page numbers in negative. I can open this dictionary object to see the details. Here is the complete text from the page having the page number 16, and it has been split into two sentence chunks. First one having 1395 characters and the second sentence chunk with 369 characters. Since we have configured the chunk size as 10 sentences, so the split and grouping happened this way. The next page, number 17, has only one chunk. Here is the text and chunks list with only one item. We can convert this as a data frame and view the records in tabular format. Let's quickly see the data. Here is the record index, page number, word count, sentence count, text, number of chunks and list of sentence chunks. You can notice here that up to sentence count 10, there is only one sentences chunk. Above that, till 20, it's 2, and so on. Here I think maximum 20 sentences are there in a page. Now there you go. This page has 22 sentences and the number of chunks has been calculated as 3. You can try with changing this sentence chunk size and see the results. The next function, split page chunks, creates individual chunks of text from the processed data. It removes the initial pages up to 5 because chapter 1 starts from page number 6. For each sentences chunk, it creates a dictionary with relevant information such as page number, sentence chunk, character count, word count and token count. The resulting list of dictionaries is returned. I'll run this function and let's see the results. Select the function and press F9. Then call the function. Variable name is given as pages and chunks. Here the page number starts from 6 and the records have been split for individual sentence chunks. That's why you are seeing duplicate page numbers. Let's open records having the same page numbers to see the text splits into sentence chunks. I am opening page number 7. This is the first chunk of sentences. It has 327 tokens in it. First part of the text split. The second chunk for the same page number has 293 tokens. And this is the second split for the page content. And finally, the function generate embeddings for each sentence chunk. Pages having a few numbers of tokens can be removed. So here I am setting the token threshold count as 25. You can optimize this threshold value by analyzing the page contents. Converting the list to pandas data frame object. Then filter out the records based on the threshold token value. It utilizes the sentence transformer framework with all MPNet based V2 model to generate embeddings. To use GPU for processing, I am setting device parameter as CUDA, calling the encode method to compute embeddings for each sentence chunk. This embedding is converted as a data frame and then saved to a CSV file for future usage. So you need not perform the pre-processing and embedding operations every time. The same data frame object is returned from this function. Let me run this function. Run the function first and then invoke this function and setting the returned data frame to sentences, chunks and embeddings variable. This embedding process may take some time. It's being completed now. Here is the embeddings for each sentences chunk. Each embedding is 768 dimensional space vector representation of a text. Next, I will walk you through the retrieval system. This file has been created for demonstrating the retrieval mechanism and have been used for the final RAG model as it is. Here I will show you how to load the embeddings from our previously saved CSV file, defines a query, and how to retrieve relevant passages related to that query. Here it imports necessary libraries including NumPy, PyTorch and Pandas. And I have added the retrieval function inside the helpers file. You will see that in a minute. Checking for CUDA enabled GPU. If it is available, device variable value is set as CUDA, otherwise setting its value as CPU. Basically, if you don't have GPU in your system, you won't be able to run the LLM locally. Load embeddings from CSV function is used to load embeddings from the CSV file. Read CSV file into Pandas data frame and it converts the string representation of embeddings back to NumPy arrays. Then it converts the NumPy arrays to PyTorch tensors and sends them to the specified device, returning the embeddings data frame and embeddings tensor. This function is just to print the top results and score for a given user query. It takes query, scores, indices and embeddings as inputs. It iterates through the shipped scores and indices and print the score, relevant sentence chunk and page number. We are taking the page number only for easy manual verification of the result. From this main function, I am invoking the load embeddings, retrieval and print functions sequentially. Here I am calling the load embeddings from CSV function, passing the file name as a parameter. Then defining a query. Here I am using a query which is related to some topics from the document. Setting the query as how to measure soil moisture. The retrieval function has implemented in helpers file. This function takes the user query as input parameter. And using the same embedding model, it generates the embeddings for the query we have passed. Calculating the dot product similarity scores using a utility function provided in sentence transformer library. These scores and indices are returned from this function. Then printing the results by calling print top results function. I am running this file by pressing Shift Enter keys. First time it will take some time to load the data. Okay, here is the results. It's showing the matching score and sentence chunk from the PDF file. This result has the highest score. If we use this as a basis for our measurement, we will get the following understanding of the readings. However, in this case we will assume that the soil is perfectly measured. So it's returning some passages related to the soil measurement. This sentence chunk has been extracted from page number 37. So let's go to that page. Here we have measuring soil moisture section, and that particular sentences it's taken from here. So it's extracting some relevant sections from the document as expected. Let's verify the next result. This also from the same page, and it starts from here, coding the device firmware till, but this is limited through software to a 10-bit resolution. All the results returned contain something related to soil moisture. That's a good indication that it's working as designed. Let's check one more result. It provides 4 analog interfaces, 4 I2C interfaces, and its specifications and calculations are also detailed later in the measuring environment temperature section. This from page number 34. Here it is, starting from here till the page end. Let's quickly run a query which is not that much relevant to our PDF file content. I am giving this query: how can we add sidechain to Ethereum blockchain? And run the file. Here the matching score is less compared to our previous query, but still it's trying to match with some words from the query with the sentence chunks in the document. The terms Ethereum and blockchains are there in the document, and so it's returning the most relevant sentences. When you go downwards, the score becomes lesser, indicating lesser matching sentences. Finally, to make the concept more clear to you, let me repeat the same experiment with another query which is not at all related to our PDF file content. I am setting the query as: explain why a tomato might consider itself the king of the salad. Just a funny question. Now let's see the results. The dot product comparison score is very less. Top matching score is only 0.2186, but still trying to find some semantic similarity from the embeddings. That is the power of representing sentences or words in vector space using embeddings. Tomato is related to farmer, agriculture, food, etc. So it's fetching sentences close to tomato from the vector space. That's how the retrieval system works, creating a context for generating prompt to be used in the LLM. Let's now move on to the RAG implementation file. Importing the necessary libraries first. The same retrieval function from helpers is used here. For downloading Hugging Face open source LLMs, you have to register and create an access token using this URL. Let me quickly open this URL and show you how to create an access token. Click on the New Token button to generate a token. Since I already have created one for this demo, not generating another one now. Once you generate access token, then for downloading LLM, you have to log into Hugging Face portal. For that, you can either use Anaconda console and enter Hugging Face -CLI space login, or use login method provided by the Hugging Face Hub library. I'll show you both options. Open an Anaconda PowerShell prompt and type Hugging Face -CLI space login and hit enter. Then paste the copied access token here and press enter. It will ask whether you want to add token as git credential. Choose Y or N and press enter. If you had followed the steps correctly, you will see the login successful message. Login method from Hugging Face library has been used here. Import the method and call it, passing the token as parameter. This load config values function is used to read configuration values from a toml file and set values as environment variables. This function has been implemented in helpers file. The function takes config file path as input parameter and reading all the entries from the file and set the values as environment variables. Calling select model function to select an open source large language model and set quantization requirement flag based on the GPU memory. Quantization techniques used for representing data with less information while also trying to not lose too much accuracy. This means converting a data type to represent the same information with fewer bits. This select model function checks your GPU memory and decide on the LLM to be used. Next, calling initialize model function by passing the selected model and quantization flag. This function first creates a quantization config object by calling bits and bytes config method from transformers object. Based on the hardware configurations, choosing the attention algorithm here. Creating a tokenizer object, then downloading the LLM model. If the flag use quantization config is set to true, then move the LLM model to CUDA device, that means GPU. And this function is returning the LLM model and tokenizer. Loading sentence embeddings from CSV file, extracting the embedding and formatting. Then convert that into tensors and sends them to the specified device. Invoke RAG is the entry point to our RAG model. First, it calls the retrieval function to get scores and indices. It extracts the context items using the indices returned from the retrieval operation. Then it's calling generate response method. That function implementation is here. It formats a prompt using prompt formatter function. Here it is creating a prompt using the context and the user query. Then it tokenizes the prompt and generates a response using the LLM model. The generated response is decoded from tokens to text. To test this model, I am creating an object of this class RAG model. Here is a list of some queries and randomly picking one from the list, printing the selected query. Then call the invoke RAG method, passing the query as input parameter. Let me run this file. Clearing the console first and run the code. Press Shift Enter to run the entire code in the file. It's downloading the LLM model. From the list, it took the query how LoRaWAN works. And we got the response as, please provide a brief explanation of LoRaWAN, including its purpose and how it differs from LPWAN. I don't think this is what we are expecting. Probably the PDF file doesn't have the required information to frame a proper answer. Or maybe the retriever didn't pick the document section properly. Don't know the exact reason. Let me try it again. When we run the code like this, every time it will download the LLM. But it will not be the case when we deploy the application and running on a server. This time it chose the question, how blockchain and IoT can help in food supply chain. And the answer generated is, blockchain and IoT can help in food supply chain by enhancing transparency, reducing human error, and ensuring provenance. Blockchain and IoT can combine to create a food supply chain that is more efficient, transparent, and secure. We got a pretty good response this time. Let's try one more time. Here is the selected question. How does integrating blockchain technology enhance security in IoT solution? And what specific vulnerabilities does it address? And the answer is, integrating blockchain technology enhances security by providing trust and transparency in IoT networks. Blockchain allows businesses to securely share and track asset data across various ecosystems, making it more difficult for malicious actors to manipulate or falsify transactions. This ensures the integrity and authenticity of data, preventing unauthorized access or modification. Additionally, blockchain technology enables immutability and tamper-proof record keeping, protecting sensitive IoT data from unauthorized modifications or hacking attempts. Yeah, we are getting a very good response from the RAG framework. We've completed the RAG implementation successfully. Next, we need to expose this as an API service so that it can be consumed from our web application. For that, I am adding an API layer to abstract the RAG functionality. This is a simple class where we are creating an instance of RAG model and calling invoke RAG method. I am creating RAG model object outside the class so that the LLM will be downloaded only once. Next, we need to have an HTTP handler that has been implemented in the app.py file. Here I am using Python Flask framework for HTTP request handler. Importing the necessary libraries for building a server component using Flask. Also importing the RAG API class. An instance of the Flask class is created and assigned to a variable app. For allowing it to handle cross-origin requests, enabling core support to the Flask. Defining the route. Here it's defining that the function should handle post request to this endpoint. Call API function is defined to handle request to the /RAG API endpoint. It checks if the incoming request contains JSON data. If yes, it parses the JSON data from the request object. This is our user input which is sent from the web application. It's instantiating an object of class RAG API, then calling sendPrompt method passing the user query. And the response is sent back to the web application. If I run this file, it will initialize the RAG model because the object instantiation happens outside the class. It will download the LLM model, load the embeddings, and creates the object specified in the initialization step. Okay, it's executing some queries and returning the results. That coding which we added for testing can be removed. This in the RAG model.py file. Commenting these lines, and to stop the service press Ctrl C and then rerun the file. This service is running on the local host at the port number 5000. It's ready to accept API requests from our web application. Now I will quickly go through the web application. My favorite IDE for developing applications using JavaScript framework is VS Code. This is a simple web application having just one page. There is no authentication or any other security features have been added to this application. Our objective here is to show you how to consume a RAG service from a client application. I have created this application using React.js framework with Tailwind CSS. This chat UI.jsx contains the core logic to read user query and call the API. Here is the text area to enter user input, and send button is provided to submit the form. Handle submit function is invoked when click on the send button or press the enter key from the text area. Handle submit function will add the user query to a state variable of type list as user input, then calling send message function. This function calls the RAG API using this endpoint localhost :5000/RAG API. That's the same localhost port number where we have set up our RAG service. Question variable has been embedded to the request object. Once we get the successful HTTP response with status code 200, I am extracting the response data and append to the messages list as bot. Messages are formatted and displayed in different colors based on the sender. Let me start the application using the command npm run dev. Application is running on the local host at the default port 5173. Open a browser and enter the URL. You can also do a control click to open this URL in a browser. Let me start with asking a simple question. How are you? Here we get I am unable to provide a response to the user query based on the context provided, as the context does not provide any information about the user's well-being. So it's strictly restricting the responses based on the given context. That's what we are expecting from a RAG model. Testing the clear button. Perfect, it's working. Let me ask another question. What is the relationship between IoT and blockchain? Here is the response. The IoT and blockchain are not the only set of technologies that are driving the evolution of a new economic and manufacturing evolution. Industry 4.0 is a concept that takes place in an era of new methods, technologies, and unprecedented computing capabilities that can be used by anyone who has internet access. Blockchain technology is a key component of Industry 4.0, providing trust and transparency to data, enabling the sharing of assets and collaboration across different ecosystems. It's not exactly telling the relationships, but giving an overview of technology advancements. Next, I will ask, can you explain about Bitcoin? I don't think anything related to Bitcoin is there in the PDF file. Right, the user query is not addressed in this context, so I cannot provide a response to this query from the context. Let me check how DLT works. That also not there in the context. Let me ask, what is Hyperledger Fabric? The response I am getting is Hyperledger Fabric is a permissioned Ethereum smart contract blockchain node that allows components such as consensus and membership services. That's not right. Hyperledger Fabric is not an Ethereum smart contract. Let me ask the same question again. This time I am getting a correct response. Hyperledger Fabric is a blockchain platform that allows components such as consensus and membership services to be plug and play. It uses container technology to host smart contract called chain code, which comprise the application logic of the system. This is absolutely correct. So we have successfully built and deployed our RAG system locally without using any LLM API service. You will be able to tweak this application to use in different use cases. Thank you for watching this video. If you like my videos, please subscribe my channel. Thank you.